Hi everyone, we will use this simple topology for this video session. We want host 1 and host 2 to be able to communicate with each other. Okay. Now host 1 and host 2 can be anything like a computer, server, virtual machine or switch. And any1 and any2 can be any networking device like a switch, a router, etc. And that's why we named them network equipment, abbreviated as NE. Okay. Now in this demonstration, I will be using Arista switches as both hosts and NEs. You will see that the syntax is just like Cisco. It does not matter though, because the switching and routing I show in this video are standard behaviors. So make sure you focus more on the process. Okay, now our goal in this video is to clearly understand how a networking device makes decisions while switching or routing the packets it receives and see the difference. So in the first part of this video, we will configure our devices for switching, okay, and then later for routing. And these are going to be our topologies for switching and routing. Now, as a refresher, when we talk about switching, that means host 1 and host 2, they belong to the same subnet. Have a look. 172.16.10.1 and 2. And the NEs here, NE1 and NE2, they forward the frames or packets, okay, based on the MAC addresses of these hosts. And when we talk about routing, that means host 1 and host 2, they belong to different subnets. And these NEs forward packets based on IP addresses as well. So let's start with switching first. Now this is our switching configuration, okay? And you can see that host 1 and host 2, we will configure the VLAN 10 and the IP address on the VLAN 10, and we will allow the VLAN on the ports. And you can see the ports are all layer 2. And these NEs, you can see there is no IP address configured on the NEs. Okay, it means that they will be just switching the packets or frames. Now let's configure our devices. So these are our all devices, and you can see I have just configured the host names for now, and there is no other configuration on these devices. They are completely blank. Now this same configuration I have in a spreadsheet, so I can easily copy paste the configuration. Okay, so let's bring my MobaXterm. Okay, this tool is called MobaXterm, which I'm using, and this is really a nice tool. Okay, now let's have these devices configured. So I'll copy and paste on host 1, and I'll copy host 2 configuration, and now I will copy NE1 configuration and paste, and here I'll copy and paste NE2 configuration. Okay, now our configuration is complete, right? Now let's verify if all the ports are configured with the required VLAN. Let me exit, show VLAN ID 10. On all the required ports, we have the VLAN. Now let's check, let me exclude NE1 and NE2 from the multi-exit mode. So now let's look at the interface VLAN 10 on host 1 and host 2. Okay, these are the IP addresses configured on the VLAN 10 interface. Please note the MAC addresses, okay, because we will use these MAC addresses later. Okay, now let's look at okay, let me bring those any1 and any2 back. Now we want to check the routing table, how it looks like, the MAC table and the ARP table. Okay, so show IP route. So as expected, we have just one in the VLAN 10, and as expected, this is empty on any1 and any2. Now let's look at the MAC table. There is no MAC entry because these devices have not communicated yet. Okay, now let's look at the ARP table. The ARP table is empty as well. Now, do you think host 1 can reach host 2? Let's generate one ping packet from host 1 to host 2 and see if the ping works or not. So I will exit multi-execution mode, okay, and I will ping, okay, and I'll ping host 2 172.16.10.2, and I will just generate one ping packet, and the ping works. But how? Host 1 has no idea where the host 2 is, but the ping worked. Now let's look at the MAC table now. Show MAC address table, and we can see on any1 and any2 we have the MAC addresses of both host 1 and host 2. Remember, these were the MAC addresses on the interface VLAN 10 of host 1 and host 2. And now look at the ARP table. Now host 1 knows the ARP entry of host 2, and similarly host 2 knows the ARP entry of host 1. And as expected, you don't see any ARP entry on any1 and any2. They are just switching the frames, packets based on the MAC addresses, right? Now we need to know what happened in the background, right? Okay, so it's the same topology. I have just changed the shape a bit, okay? And you will see why I did that shortly. Now, we want to know what happened in the background, that the MAC tables were empty on all of these devices, but the ping still worked, okay? Let's see what happens. So something happened in the background, and that is called ARP resolution. Host 1, okay, before sending out the ping packet, host 1 needs to know where to send the packet, right? And to find the MAC address, there is a process called ARP resolution, okay? So in the background, host 1 performed this process, ARP resolution, before sending out the ping packet, okay? And the process is to just know the MAC address of host 2. So it's a request like, who has 172.16.10.2, please send me your MAC address. Okay, so as soon as you hit the ping command, okay, the host 1 performs a subnet mask check, and it finds out that the host 2 resides on the VLAN 10 because this IP address is configured on the VLAN 10 and it's in the same subnet. So when it performs the subnet mask check, it finds that it's in the VLAN 10. So I need to send the ARP request to this IP address, which is in my local area network. Okay, so it's the payload. The ARP protocol works on layer 2. So, and this ARP request is then encapsulated into Ethernet frame, okay, and it has the tag inserted because we have to send the, because host 1 has to send the request in the VLAN 10. And now the source MAC is its VLAN 10 MAC, okay, and look at the destination MAC address, FFFF. What does that mean? It's a broadcast address because host 1 has no idea where this 10.2 resides, right? So it has to send this ARP request packet out all the ports where the VLAN 10 is configured. In our case, it's just configured on Ethernet 1. Okay, so it sends out this request packet to anyone. When this whole thing comes to anyone, anyone looks at the destination MAC and it concludes that I have to broadcast this frame out all my ports where I have VLAN 10 configured, except the port where it received this packet on E1. So it will not broadcast or flood this packet out E1, but it will send it out E2. Okay, and before doing that, it will update the MAC table because it's the first time anyone received a packet from host 1. So this is a standard behavior. So anyone will update the source MAC, you see here in the MAC table, and the port where it received on, and the VLAN, and then it will send this out to NE2. It did not change any entry in the packet. So when this packet comes to NE2, it will do the same. Okay, it looks at the destination MAC address, FFF. It means that it needs to broadcast this packet out all ports except Ethernet 2, and it will update the MAC table that it received the packet from this host, from this port, and in this VLAN. And finally, it will broadcast the packet on E1. Okay, and finally host 2 receives the packet. When host 2 receives the packet, we have an IP address configured on the VLAN 10 on host 2. So host 2 will perform a check on the ARP request, and it finds that, okay, this 10.2 belongs to me. So I am the one. I have to respond to this ARP request. So I have found that it's a very good idea when you are trying to understand a concept, you act like the device. So act like host 1, act like NE1, act like NE2. And here you act like host 2. So host 2 will perform that check, and now it knows that, okay, I am the one. I have to respond for this ARP request. So it will update the MAC table, and it will also update the ARP table because it received an ARP from this host, host 1, and the IP is this, and the VLAN is this 10. Now it has to respond. So now look at the ARP reply. Now what happens is host 2 will reply back to host 1. And now look at the source MAC. The source MAC is host 2 MAC, and the destination MAC address is host 1. Okay, and this is the VLAN 10, and this is the payload, the ARP reply. And look at the destination IP, .10.1, and the source IP is .10.2. Okay, and it will send this packet to NE2. When NE2 receives this packet, it will look at the MAC table. Remember, it had this entry to host 1, EE0B. So it knows now where to forward this packet. Okay, so now what NE2 will do, NE2 will update its MAC table with this source MAC which belongs to host 2, because it's the first time host 2 sent any packet to NE2. So it will update the MAC table. Okay, now NE2 has both the MAC addresses for host 1 and host 2, and then it will send out the packet to NE1. Okay, and similarly, when NE1 receives this packet, it will update the MAC table and then forward this packet to host 1. And when host 1 receives ARP reply, okay, it will update the MAC table with this source MAC which belongs to host 2, and then it will also update the ARP table. Now host 1 can send a ping packet. You see, it was all happening in the background. So now host 1 knows where to send the ping packet. Now it's the payload, okay? Because ping operates on the network layer. So you see the IPv4 header, okay? And this whole payload will be encapsulated in the Ethernet frame, and the VLAN tag is inserted because all this communication is happening in VLAN 10. Okay, and when host 1 sends this packet out to NE1, NE1 looks at the destination MAC, okay, and it knows that I have to send this out my Ethernet 2. Look at this entry, okay, and similarly it forwards the same packet out Ethernet 2, and when it is received by NE2, it will forward it to host 2. Now host 2 receives the ping request, and it knows that now I have to reply back to this ping request, and see here. Now host 2 will reply back to the ping request packet. The source MAC is its own MAC address in on the interface VLAN 10, and you can see the VLAN tag, and the source IP is its own IP, and the destination IP is the host 1. And this is now the echo reply. So it's the payload. Okay, and similarly the same process when it is received by NE2. Now it knows where the packet is coming from and where it's going. So it will just look at the destination MAC address, and it will forward the packet out Ethernet 2, and similarly NE1 and host 1. So when the host 1 receives this packet, you see this, thing. Okay, at this point you see a reply. So you can see that all this process was happening in the background. Okay, now let's look at the routing example. First of all, there are different ways to implement routing in this scenario, and this is just one of them. So now you can see that host 1 and host 2, they are in different VLANs, and they are assigned different subnets. And between NE1 and host 1, we will allow VLAN 10, and between NE2 and host 2, we will allow VLAN 20. And now, because host 1 wants to reach host 2 in the different subnet, so it needs a device, a default gateway that can perform a routing. So for host 1, the default gateway will be NE1, and for host 2 it will be NE2. So now on NE1 and NE2, you can see that we have assigned one IP address from each VLAN. On anyone, this is the second IP address from each VLAN, and on any2 it's the third IP from each VLAN subnet. Okay, and there is a reason for this. Okay, remember this one thing about routing and you will never fail at routing. And the thing is, a device that needs to perform routing, okay, it needs to have some entry in the routing table that matches the packet's source IP and some entry that matches the packet's destination IP. So suppose host 1 wants to reach host 2. It has a source IP of 172.16.10.1. So when the packet comes to any1, okay, and destination IP in the packet is host 2 IP, okay, this anyone should know in the routing table about both the IP, source IP and the destination IP. This is very important. Otherwise, you cannot have successful communication between the devices. This behavior is different than switching. In switching, it's fine if a device does not have the source MAC address of an incoming frame or packet. It's fine. It can just update the MAC table with the source MAC address and it can forward the packet. But that's not the case with routing. You need to have some entry in the routing table for both, for the source IP of the packet and the destination IP where the packet needs to be routed to. Okay, here we have this command IP routing on all the devices, because in this example we will be doing routing. We have a default static route in both host 1 and host 2. It means that anything that is different than the VLAN 10 subnet, just route the packet to any1. And same is the case for between host 2 and any2. And now look at the configuration of NEs. Both the NEs are configured with one IP in each VLAN, and between any1 and any2 we have to pass both the VLANs. Okay, so now let's jump on to the CLI. First of all, let's remove the switching configuration. Now these devices are again blank. We don't have any configuration on these devices except the host names. So now let's go to the routing example, and I will just copy paste. This is for NE1 and this is for NE2. Now let's confirm we have the required VLAN IDs on ports. It looks fine. Now let's have a look at the routing table. Show IP route. You can see we have a default route in both hosts, and you can check on both the NEs. We have a route to each subnet, which is very important. Okay, so it's fine. Now I want you to have a look at the MAC addresses on the VLAN interfaces. One thing that you will note that like on any1 and any2, the MAC addresses on both the VLAN interfaces are same. That's absolutely fine, because this is the system MAC address and it's assigned on each VLAN. And you can see same here for NE2. Okay, now let's look at the ARP addresses. Okay, so this behavior is a bit different than switching. Here you can see that we have ARP entries. Like host has an ARP entry for its default gateway, which is NE1, and NE1 has an ARP entry for host 1, and similarly host 2 has an ARP entry for its default gateway, and NE2 has an entry for host 2. Why? So let's have a look what happens. So as soon as you hit this command, IP route, the default static route commands, okay, host 1 and host 2 will immediately request for the MAC address of their default gateways. It's a standard behavior. So look at this. So host 1 will request the MAC address for the default gateway. You can look at the source IP. Okay, the source MAC, the destination MAC is unknown. Okay, and the destination IP is 10.2, which is here. We mentioned here in the static route. So, and finally, the payload will be encapsulated in the Ethernet frame. Okay, and in the Ethernet frame, this unknown MAC address is represented as FFFF. So this packet, when it reaches on NE1, okay, now NE1 knows that it has one IP address configured in VLAN 10. So now it will check the payload. Okay, so when it checks the payload, it finds out that, okay, this R packet is destined to me because this destination IP is same what we have configured on the NE1. So NE1 knows that I have to respond to this ARP request. Okay, so it will update its MAC table. NE1 will update the ARP table, and then it will respond to host 1. And same is the case between host 2 and NE2. So let's look at the ARP reply. So in the ARP reply, NE1 will reply back with the source MAC of, you see, the VLAN 10 and the destination MAC host 1, and the VLAN is 10, and the source MAC in the ARP request is its own, and you can see rest of the entries here. When host 1 receives this packet, it will update its MAC table and the ARP table. And similarly, host 2 will update its MAC table and the ARP table. So now let's send a ping packet to host 2 and see if it works. Ping 172.16.20.1, and I will just send one packet, and the ping works. Okay, so now let's look at the ARP table now. You can see that host 1 and host 2 both have the ARP entries of NE1 and NE2, and similarly NE1 and NE2 both have ARP entries of host 1 and host 2. Now let's look at the MAC table. Okay, all these MAC entries. So now let's look deeper what happened in the background. Okay, so now when we hit the ping command on host 1, we say ping 172.16.20.1, okay, on host 1. So when we press enter, host 1 will perform a subnet mask check, okay, And when it performs the subnet mask check on the destination IP, it finds out that, okay, this IP address is not in my VLAN 10. So I have to send this packet to my default gateway. Okay. And it has that entry in the MAC table and the ARP table. So it will perform a lookup in the MAC table and it will send the packet out to anyone. Okay. Now when anyone receives the packet, it sees its own MAC address here. So it knows that this packet is destined to me and I have to perform a routing. Okay. So it checks the payload for source and destination IP. It finds out that, okay, I have the source IP in my routing table. I have a subnet. I can show you. We just check that. Here. So the source IP matches this subnet and the destination IP matches this subnet. I told you this is very important for routing. Both source and destination IP needs to have some entry in the routing table. Okay. So now anyone knows that the destination IP belongs to this VLAN 20. But the problem is anyone does not know where the host 2 resides, where this destination IP address resides. And we know that when a device wants to find the MAC address, it will use ARP resolution. So what happens is, anyone will send an ARP request to host 2. Okay. And now this time the VLAN is VLAN 20 in this case, and it will send the request out. So when this request reaches NE2, NE2 will update its MAC table. Okay. And it will broadcast the request out E1. Okay. And ultimately host 2 receives the ARP request from NE1, and the host 2 will update its MAC table, and it will also update the ARP table. Okay. Now host 2 needs to send an ARP reply. Now the host 2 will send an ARP reply to NE1. It will put its source MAC, the destination MAC of NE1, and the VLAN and the payload, and it reaches NE2. And when NE2 has an entry for NE1 already in the MAC table, so it will forward it to NE1. Once NE1 receives it, it will update its MAC table and the ARP table. Okay. So now NE1 has the MAC address of host 2. So now it will send the ping request packet. Now it will send it out to NE2. So when NE2, and please notice one thing, when NE1 sent out the ping packet, it has to rewrite the Ethernet frame header. See here, when host 1 sent the packet to NE1, the source MAC was its own and the destination MAC was NE1. But here, when NE1 is sending out, it is rewriting the Ethernet frame header, and now the source MAC is itself, but the destination MAC is host 2. However, the payload remains the same. The source IP is still the host 1 and the destination IP is still the host 2. So please take note of this thing. And now when this ping request reaches NE2, NE2 will perform a MAC table lookup, and it can see that destination MAC is this one and it's there in the MAC table, and it will send out the frame on its port E1. And now when it reaches to host 2, now it needs to respond. So now the host 2 sends the ping reply to host 1, and it will send the reply to its default gateway because the destination IP falls in a different subnet than this the VLAN 20. So it needs to send it to its default gateway. So when NE2 receives this packet, okay, it sees the destination MAC address and it knows that this destination MAC belongs to NE2. So it means that it needs to route the packet. So when it will check the payload, it finds out that NE2 does not have an MAC entry or an ARP entry for 172.16.10.1. So again, NE2 will perform ARP resolution. Okay. You can see here that the NE2 will send an ARP request to 172.16.10.1, and please note here the source MAC is itself NE2. Okay, and then the same process, the request comes here and the MAC table will be updated. It comes to NE1 and then the host 1, the host 1 will update its MAC and ARP table, and then it will send a response back. Okay, and the same process, when it sends the response back, NE2 will update its ARP and MAC table. Now it has the MAC address of host 1. So it will send first of all, it will rewrite the Ethernet frame header, because you can see here the source and destination and the VLAN tag are different. But here you can see that the source address, the source MAC, the destination MAC, and the VLAN, they are different. Okay, because NE2 had to perform a routing, inter-VLAN routing. Okay, so it will rewrite the Ethernet frame header and it will send the packet to NE1. NE1 will perform MAC table lookup and it will send out the frame out on Ethernet 1. And when it sends this frame out, it will be received by host 1. Okay, and when the host 1 receives this frame, you see this.